Hello, Dr. Satya, can you hear me?
Yes. Hi, Sanjit.
Okay. So, very good afternoon to all the participants. For this session, we have with us Dr. Satyanarayana as the guest speaker. Before he start his talk, let me take the privilege to introduce him. So, Dr. Satyanarayana is currently Senior Security Architect, Vice President at Citibank, Ireland. He was a Senior Research Scientist at United Technologies Research Centre, Ireland. He held various research positions at the Interdisciplinary Centre for Security, Reliability and Trust, University of Luxembourg, University of Edinburgh, and Jacobs University. He received the Bachelor of Technology degree with distinction in Computer Science and Engineering from JNTU, Kakinada, India in 2009, and the Master of Technology degree in Information Security from the National Institute of Technology, Durgapur, India in 2011. He received the PhD degree in Electrical Engineering from Jacobs University, Germany in January 2015. He is a certified information systems and security professional and also senior member of IEEE. He has authored more than 70 publications in referred international journals and conferences. His research interests are cyber physical security, Internet of Things, content delivery network, wireless communications with particular focus on 5G. So with this small introduction, I hand over the session to Dr. Satya.
Thanks, Sanjit, for your kind introduction. Okay, everyone, good afternoon. Let me share my screen and then maybe we can start. Okay, you see. Can anyone confirm?
Yes, yes, it's visible. Just full screen. Yeah, perfect.
Okay, thank you so much. Okay, so in this talk, we are going to talk about advanced persistent threats with particular focus on critical infrastructures. And by the way, you can call me Satya. I know Satyanarayana is a bit difficult to pronounce for some of you. So please call me Satya. And yeah, in this talk, we are going to talk about APTs. So maybe I just let me give you what is the definition of APT first of all, and then we can continue. So I know here maybe some of you might from cybersecurity domain, some of you might not be from cybersecurity, right? So the talk could be like it's a kind of both technical and non-technical. It's so that everyone can benefit it. So what is like in APTs, advanced persistent threats? So let's define what is persistent. So I mean, if you find the dictionary, so it defines which occur in a prolonged period or like it's continuing to occur. So basically, APTs are a kind of attacks which occurs over a long period of time. So that means which has some strategy, which has some kind of method to execute. So it's not like a simple denial of service attack or simple injection attack something, but it has some kind of previous work they do. I mean the attackers or whatever when they are who are performing APTs, they perform some kind of research and they'll wait and then execute this attack. So we can go very detailed in the coming slides. So here in this presentation, we are going to discuss more on from the perspective of critical infrastructures. So let me define critical infrastructure also. So every day you come across many organizations like our enterprises or product. So but they are like the infrastructures which does not involve any physical world or like maybe for example consider a finance financial domain, for example banking. So here you involve, it's more about networks, right? It's more about network domain. But here if there is some cyber attack, you're going to lose the money or monetarily loss. It's not a something, it's not a some not you don't have any physical effect, something the human life is not in danger. But where is in critical infrastructures, so there is a specific effect on a physical world. So that's why like the attacks at in a critical infrastructure on critical infrastructures has a different effect and compared to normal cyberspace. So that's how we can differentiate cyber physical world and cyber world. So today, like before going to the agenda, I just wanted to show you just explain you the concept of the traditional security system that we follow from a century, right? So the security is not a new topic for to all of us, right? So we hear from the security, traditional security, from the since existence of the human life. I mean, slowly we adapted the security. Like for example, in back in centuries, we have a kingdom which has a fort where king is basically residing. So you wanted to protect the king. So then you see different, as you see in the picture, you have multiple layers of defenses, right, to protect the king. So from initially at the starting level, you see the perimeter, maybe which is covered with the water, and then you have an internal layer defense. So there are multiple layer defense and defense in depth. That's how the traditional security system is built. So now, if you map this traditional security to the modern cyber security world, which almost is like very similar. For example, consider any enterprise security or infrastructure security. So you have some, you wanted to protect some financial domain or some other aerospace sector, whatever. So like you are working for a company, so you wanted to protect the particular company's assets, right, the entire infrastructure. Okay, so how basically they build is basically you have firewalls, right, at the perimeter, at the starting level, the basic firewalls, and after that you have a DNS servers. Maybe then after that you have an internal DMZ, demilitarized zone, and there are some kind of, maybe at some point you see honeypot kind of. There are different layers of security that we are building in modern system also. So by mapping the traditional security system, right? I think, I mean, we should agree, right? The cyberspace, the modern security systems are not so different from the traditional security systems. So yeah, that's how we can start the cyber security, cyber physical or cyber security infrastructures. So now coming to agenda, today maybe we can discuss about bit about IoT, Internet of Things, and we can discuss bit about like what is cyber physical security, and we can also discuss about the security life cycle, and some how at the end we're going to discuss about how explainable AI or how machine learning techniques are helpful in order to find these intrusions intrusions when on your network. Here maybe you might be wondering why I'm talking about IoT, machine learning and cybersecurity on a single presentation, right? So but the fact is cybersecurity is not a standalone topic. It's a pure interdisciplinary topic, right? So you need to have some basis, then only you can apply cybersecurity on top of it, right? For example, here map to the traditional security system, you have a kingdom and then you have a fort, then you are applying multiple layers of defense security to protect the king. So similarly, you need to have some base, then only on top of it you apply this technique or cyber security methodologies to protect the particular resources, right? So I'll say IoT is a very good example to start it, because which has so many flavors, like it has a cyber physical flavors, and then they are easily to attack prone-able, right? IoT, because it is emerging domain. So you see, and which is has a lot of connection with the cyber physical world, right? I mean physical world. So that's why I wanted to define IoT a little bit, and after that we start with the cyber physical security, and slowly we can go to the security life cycle. So here the presentation is structured with respect to security life cycle. I'll explain you more in the corresponding slide. So why I'm talking about security life cycle? I know security life cycle means is maybe you might think it's a very basis, but it can you provide a structured way to define content. So that's how we can start, and at the end we'll end with some machine learning approaches and some takeaways. And by the way, before going to another slides, if you have any doubts, please feel free to stop me. And it's more interactive. I don't, we don't need to be really formal. We can at the end. You don't need to ask the questions at the end. I mean, Sanjit, if you are okay, they can. It could be interactive. It's
Yes,
okay.
yes, I'm okay. Yeah,
Thank you.
participants, if you have any questions, please stop him and ask in between. Yeah,
Thanks.
please go ahead.
Thanks, Sanjit. So, okay, first define IoT. As we said, cybersecurity is like, depend, like it's a interdisciplinary topic. So first of all, what is IoT? I know like most of you here, I mean, we know this IoT from a decade, I think almost. So I was working on a project in 2011 to 2013 on a European project called Butler. So this project basically trying to provide some, IoT services on a specific use cases. So the use cases that time we considered smart home. So the smart home scenario, basically we wanted to you know save the energy, or you wanted to control the your control the appliances, right? So you wanted to have a ease of access while you were interacting with your with your devices in your home. So that's how, I mean, the IoT basically started with the, let's say, the base, according to my understanding, the smart home is like a best use case to start the IoT definition. So what is, maybe before even going to the use cases, maybe we can define what is IoT. IoT is nothing but it's an interconnection of a set of smart objects for the purpose of exchanging information to gain some services, right? So now map to smart home where there are a set of objects you install on your home, like maybe it could be your fridge, or it could be your oven or something, maybe your air conditioner or smart air conditioners. So these are the set of objects and which are connected, each other, and they wanted to exchange the information to get some services, like you wanted, as a user, you wanted to control on a single, with a single device. So that's the basic definition of IoT by mapping to smart home. So now let's go to the other use cases. Smart health, like you wanted to take see the medicine intake, or like you wanted to some guest assistant while you were, for example, you were taking some medicine, or for example, you wanted to take some tablets. So IoTs basically can help you how you can take, because sometimes you wanted to do some kind of exercises, for example. So you don't know how to do it, but the devices sensors, if you can put it, and then they can guide you. Okay, you have to do it in a particular way. So there are different ways that you can use IoT in smart health use case. Similarly, smart transport. So for example, you wanted to do the carpooling, or maybe you wanted to avoid the traffic jams, identifying the alternative routes, these type of things. I mean, you'll get a notifications from your devices based on the time you leave from home. You don't need to basically open the Google map. Okay, you can just leave the home automatically by 9 o'clock or something. Generally you follow this procedure, so it will guide you how, to help you to get the route, for example. I mean, these use cases, I mean, one thing we need to understand, these use cases are not standalone. Sometimes the use cases are like, could be vertical use cases. Sometimes they could be very horizontal also. I'm going to talk about horizontal scenarios also. Now, smart city, something, for example, you are in a, you are just, I know last year we shared about in Delhi or some spaces, you have the air pollution, and it is a big issue. That time, maybe you have a smart system. So maybe you're trying to avoid the particular areas. So for example, someone installed some sensors, smart sensors, air conditioner sensors, okay, controls, so that you can get the live notifications. Okay, maybe you avoid the particular route, so to be safe. So similarly, for example, you went to shopping, okay, and now you are in a section milk, where the milk section is, you are just trying to enter in a milk section. So then you get the deals immediately. Okay, there is some offers on milk, or maybe for entering the chocolate section, maybe you'll get some offers on chocolates. So but here one common aspect is contextness, right? So how are you getting the notifications, or like how you are avoiding the traffic. So here the contextness is one of the key factors in while you are providing any IoT solution. So like said, so here in order to enable such a use cases, you need to have a three different horizontal technology enablers. For example, you need to provide a geotemporal localization, and you need security and privacy, of course, which is a core important aspect of IoT, because here we discuss about security, but we are going to discuss about security. But privacy is another context, because here IoT means you are dealing with your personal information a lot, right? So the privacy also very important concern that has to be addressed, and to look in future. And the context awareness. So as I said, you have to uh, enrich the system with knowledge and information to provide the services. So here, that's the IoT scenario. Last, what we discussed about smart health, smart home, this smart transport, like there are five use cases that we are discussing, but that's in a decade before, like 2011 or 13. But now if you see, it has changing slowly. Now you from last 4 5 years, you started hearing about industrial IoT, IIoT, industrial IoT, and then IoT is this use cases span to different various sectors. Now you see smart airport, you wherever you go, smart health. There are different, even for COVID also we develop there are different use cases for from IoT. So as you see, now we are going from IoT term to IoE, Internet of Everything. So you are basically connecting everything together, all the objects you're making, trying to connect together. So in order to connect in order to enable such a platform, you need to have interoperability. Like as you see in the right side, you need to have interoperability, scalability, and security. Okay, so that's how, like, why I'm discussing about IoT or IoE, because I wanted to bring what is the importance of cybersecurity on at IoE level. So here, as a requirement, interoperability is a one requirement, right? For example, you wanted to, so in the one example, there's a horizontal scenario that, for example, you are at home, you are in a, like, let's say you wanted to go to office, okay? You are from in the home. So you are starting at 8 o'clock, and then automatically your lights and everything should be turned off, and then it should be adjusted to according to your time. And then when you take your car, you need to get a safest route, in a shortest and safest route, and then you need to get a parking at your office. So this is a one horizontal scenario. But here you are going to use multiple devices, right? So multiple devices, each device has operate in different frequencies, and which has different and different security levels, for example. So how you can incorporate such a requirements, right? So for example, to address interoperability, maybe you need to have a cross spectrum coexistence. For example, while you are your routers are like should you have multiple bands, it should address, it should accept multiple frequencies, right? For example, you're switching from one network to one network, right? Was you're switching from one vertical scenario to another vertical scenario. So in order to achieve this such interoperability, you need to have a radio access enabled technology platform. For example, 5G, like millimeter wave, LoRa, or like NB-IoT is specific to IoT band, you know, communication band, and maybe you might use LTE. Sometimes you might use Zigbee or Bluetooth, right? So your devices should be interoperable. That can be achieved by radio access enabling platforms. And similarly, you wanted to have scalability. You wanted to have scalable, like it can be, I mean, any number of devices you are adding. For example, like your system should be scalable to 10 devices, or should be scalable to hundreds of thousands of devices. So you need to have such a 5G networking, slicing. I don't know. I'm not going to in detail about 5G concepts now, but 5G slicing, NFC network installation function should be enabled to achieve this scalability. Now coming to security. So here you are dealing with such a interoperable devices. As I said, you are talking with the multiple different frequencies and different bands. So the security, I mean, when you talk about from communication, I mean, from physical layer perspective also, that attacks are different. I mean, you might see, I mean, if you see the attacks scenario, if you consider OS layer stack, network stack, you have from physical layer to application layer, right? So when you're talking about communication branch, communication frequencies, you're talking basically the physical layer. The attacks at the physical layer are different from the attacks at the application layer. So the different, for example, the attacks happening at millimeter wave, for example, millimeter frequency, might not happen at normal frequency, because I give you one very plain example. Millimeter wave band, for example, it has a high frequency. It has a, like, narrow, let's say, high frequency width, and it will give you high intensity. So it's like a like point to point connection. Some, for example, if some attacker wants to obstruct the connection, he can directly put some object in between, then your communication channel could be disturbed. But whereas in radio access network, for example, your mobile network, so if you put a device or something, it does not obstruct because of the millimeter wave, the wavelength. So what I'm trying to say, the security, when you're considering this type of IoT or, like, 5G, it varies. So you need to think, when you are protecting any system, you need to think from a different layer perspective, different ways. So okay, that's how the security could be plays a major role depending on the type of network you are building. Okay, and then you need to identify there could be privacy and security issues. So that's how IoT plays crucial role in our daily life, and security also plays a very crucial role in order to protect such systems. So okay, till now we were discussing about more about IoE, internet, 5G. I mean, I was talking about more, I was giving more, fancy buzzwords every time, right? I was talking about IoT systems. I was talking about Industry 4.0 and 5G, machine learning. I know, like, it's confusing, but in fact, the current systems, whatever the system you are, like, kind of mix of this network, right? Our cyber physical world now is changing a lot. It's not like, you need to this is a mix of different technologies. So from, as you know, we are changing from a cyber world to cyber physical world, right? How say maybe I can give another example. So in back in 1940s and 1950s, you have a home with the normal fan, normal light, okay? And slowly in 1970s, you started using telephones, or, like, portable TVs at your home. From 2000 onwards, you started having computer at your home, and then you have internet. Okay, from 2010 onwards, you are connecting your laptop, your mobile, you are in the cloud, and then you are connecting all the device. So as you see, from in a, let's say, span of 75 years, the cyber world, there is a physical world, and there is electronic world. And then slowly in 2010, now you see cyber physical world, right? You can control everything, and everything is connected basically. So when have that such type of cyber physical world, uh, then you likely to see more attacks from a cyber physical domain, not only from cyber domain, as I was trying to explain you in the starting of this slide, right? So cyber physical attacks are way different from a cyber attacks. So for example, there is some time before, global, Saudi insider likely to key to uh, Aramco cyber attack. So for example, there is some attacks that we see in Saudi. It's affecting some particular control, particular cyber physical infrastructure. For example, I remember it is something related to a nuclear infrastructure. So there is a cyber physical attack. So it could have been a major impact. So I mean, if you don't remediate it within a due time. So that's how cyber physical attacks could look like. I mean, it could have a major impact. Now, maybe from this slide, what I'm going to define more like some security life cycle, and with respect to the standards, and then we can follow this life cycle during in the rest of the presentation. What I mean is, So for example, if you consider any ISO 27000, 2013 version, or new one is coming 2018 version, or NIST from USA, or ENISA from Europe, these standards basically helps us to implement the information security management system in a structured way, basically. So this helps you, it provide you the guidance how you can implement one ISMS, information security management, in your enterprise or organization or at your product. They basically standards provide set of standards, rules and guidance, right? So on a very high level, ISO 27001 series provides you set of key steps. First of all, you need to have policy management, and you need to have risk assessment and control implementation and detection mitigation. So if you talk about policy management specifically, so here what it's saying that you need to have a high level, I mean, from C level, C suite, I mean, means, from in an organization, from a high level, from a CEO, or like from a chief security officer. From that point, from that level, they need to commit for the security. Like, I wanted to protect my network. So if you have that commitment, then it comes to down to the down to the developers, or the people who are implementing security controls. They can start implementing the security, right? So the policy management basically defines you a set of policies that I'm going to take care in my organization. Okay, for example, email policy. So otherwise, bring your own device. For example, I'm a chief security officer. I'm working on a aerospace sector. Maybe I'll say that you cannot bring your USB drives to the office. Okay, if you, I mean, it could be infected, right? So there are some kind of policies I define, and I'll say that, okay, I wanted to protect my networks from this specific class of attacks. Maybe I wanted to protect from APTs. Okay, whatever the APT is happening, I want to protect my networks. So that means you need to implement the specific suitable controls, right? Because if you implement controls, means, I mean, the tools, like like the security mechanisms that protect your assets. So you need to implement, like, you will choose that type of the specific class of tools in order to protect your networks. So that's policy management. And the second is the risk assessment, where you are going to define the requirements and challenges in your architecture. Something like, so more like a assessment, threat assessment, risk assessment, or threat finding. So you will see your networks and see, okay, my since, for example, I'm developing a website. So it is, which is in internet, I'll put it on I'll host it on a domain. So it could, so everyone can access. So maybe immediately someone can do the DOS attack, denial of service attack. Someone can, flood my network, flood my entire inside network. It could happen, right? So you need to see what type of attacks can happen on my network. And the other one, once you identify the network threats, you need to implement the security controls. Like, for example, I'll implement some security solutions on my networks or at product level. And then after that, you can, once you implement it, but you need to continuously monitor your system, right? So you need to identify what you need to deploy some monitoring solutions to identify what attacks are coming in my network, and then mitigation. If I see any attack, I have to react immediately. Okay, how can I mitigate? So should I shut off this network, or what should I do? So that's called mitigation. So then in the presentation, rest of slide. So we'll we can go with respect to these categories. So in cyber physical risks, so just play an example here. According to USA military report, the when you assess any program, and for example, you did a risk assessment on your network, on your product, for example, and you identify some risk that look like a tip of iceberg, but actually in real time and practically, once you deploy, most of the time you will get to know what are actual vulnerabilities that are existed underneath. That's like the tip you will see. Basically, you are going to 95% of time you are going to miss many scenarios, attack scenarios. I mean, say most of systems that we build. I mean, I'm not talking about everything. I mean, every sector, but there are some sectors we basically miss the lot of we don't cover a lot of attack scenarios while you're implementing the control. So that's a one good example for how risk assessment is performing nowadays. So that's I'll say it's more now till now it's more about the introduction, like talking about the Internet of Things, talking about what is cyber physical security and how it's look like how security life cycle look like. Now is more we're going to do more about risk assessment. That means I'm going to talk about attacks, how attacks look like from an embedded level to application level. Like let's say, okay, because critical infrastructures, you cover it from a device level to like embedded device level to the application, right? So from a product, I mean, from physical to cyber. So I wanted to cover one specific class of attacks called side channels. I, uh, I don't know exactly, maybe some of you might hear this attack, but actually I don't know this attack until I started working on this one. Okay, so I'm also that time when I started working, it's quite new to me. Okay, so I'll give a small example here. So for example, you wanted to uh, uh, break any crypto system. Okay, for example, I think this talk is the seminar. Maybe Sanjit can correct me. This I see it's a cybersecurity and cryptography like session, right? So maybe you might hear some talks from cryptography perspective. So you might have some already you heard about something on cryptography, right, Sanjay? You might have
Yes,
some.
yes, yeah.
Okay, so it's interesting with respect to cryptography. So, for example, you have a advanced encryption standard or DES, as you heard. So you wanted to I mean, for example, there is a system, there's communication channel, or there's some system you protected with you implemented AES on this particular system, okay, or DES. Then you wanted to break this one. You wanted to identify what is the key, what is the key, because for any cryptographic algorithm, the key is the core part, right? The key, if you know the key, then you know what you can identify from plain text, from ciphertext. You can get the plain text. So if you get the plain text, that means that's done, because you so that's so for example, give you an example. You have a username and password you are entering on a some website. Okay, so you wanted to break this password. On a traditional brute force approach, if if this web system is implemented with AES, for example, so you wanted to identify what is the password, right? Then if you try different number of passwords, you are enumerating like a brute force attack. It takes thousands of years, right? Because the work factor, the work factor is nothing but um, the amount of time required in order to break a particular encryption system. All right. So the work factor for AES is thousands of years, hundreds of years at least. No one has that much time to break, that much time to break particular system, right? So what attackers, attackers like researchers, sorry. So what attackers come up with an approach called side channels. So side channels, nothing but some leaked information. So I'll give you another one more bad example. Please forgive me. So for example, I have a friends here. So they have a kid. They wanted to talk, but the kid don't wanted to understand what they are talking. Okay, there are scenarios. We will generally every day we'll come across this type of scenarios. So what they do is they'll talk in a different language which he don't understand, but the kid still will get some words. Okay, somehow he'll get a context. So that means while they're talking, there is some leaked information, like unknowingly, right? So similarly, now map this specific example to our real processor world, our cyber physical world. For example, you are running some operation on your laptop. I mean, I'm giving very plain example. It might not really true. You are running on laptop. So, for example, you are running heavy operation, like maybe you are simulating some MATLAB script, okay, for example, or something. So then you might see your power, the noise levels, okay, in your fan and the power, the cycles are really going up, right? From the noise, you can say that, okay, I can sense, okay, I'm outside person. I can say that, okay, maybe he's running a very heavy operation, okay. So that means that is a leaked information, basically. So that's here. Similarly, what happened is, coming to now, I was talking about IAES and data encryption standard DES, right? So what happened is these algorithms also susceptible to side channel attacks. So that means while they are running these algorithms, they are leaking some information. What I mean is, for example, you are running AES on a processor, single. I mean, I'm talking about a very single monolithic architecture. I mean, I don't see like multi-core, multi-processor. I'm talking about like very back in and 20, 30 years before, like even before. So while you implemented AES or DES on this particular processor, and then this, as I said, this AES is susceptible to side channel, means whenever they are exchanging some information, the power, you might see a power spike. When you, for example, you connected a probe to the system where it's running, then you can see there is a power spike, but you don't know what is it is. There's a power spike has happened, but you don't know when it happened. I mean, you know when it might happen, but exactly you don't know what is the value, for what value, what key, what ciphertext value, what key value it happened, that you don't know. But you know at what level of this algorithm it might happen. So if you see any AES and DES algorithm, so basically you have a 10 different rounds, and there are substitution box, permutation box. There are different operations, right? So specifically in substitution box, S box called S box. So that time, basically you do the inverse mapping. I think non-linear mapping. So you map from a one value to another value. I mean, very plain words. Then you will put it in memory. When you will exchange the word byte from you will exchange from a normal to, I think, from secondary memory to first memory, primary memory, then you might see one power spike because of exchanging some operation from memories. So this type of, so that means I know that when he's the particular this system, when they are using SBox in AES algorithm, there might be a power spike. So what if I build a encryption system? I'm not encryption, like some model, some machine learning model, or like template or some model, so that I can capture this information. I can get the key. It is possible basically. So for example, what they did is, so as you see from in the picture, so you have a device. Okay, you have some device, a system which is running your plain text and your password. You gave the password, I mean key, okay, and you are running on processor, and this processor did the leakage, because it could be the leakage from power. I gave the example from the power perspective, but it could be time also, timing. So it could be electromagnetic radiation. It could be any. I mean, the leakage could occur in a different ways. Okay, so considering the power example, this spike. So then you can build a model. You can analyze and you can build a model. So when it can occur, then from the correlating this information, then you can break the key, which is like, for example, as I said, to break AES and DES by brute forcing, the work factor is thousands of years and hundreds of years. But from the side channel perspective, it's a fraction of seconds. I mean, you can literally, you can break the key in a fraction of seconds. I mean, the inside channel, specifically from side channel class of from this perspective, they call number of traces. So for example, the number of, I mean, they calculate the strength of the system from a perspective of traces. So in how many traces you can break the key. That means the trace means here the one time run. For example, you are running your system for one time, for example, okay, that's one run. So you give another key or another, so basically you might not have the control of the key, because here you wanted to break the key, like you wanted to know what is the key, right? So but you might have the control of your plain text. So how come means, for example, consider critical some product, so which is mass produced, okay, then you buy this product, okay, bring to your home, and you can do the reverse engineering, right? So you can connect a probe, but the key is like BIOS key. For example, you have a BIOS key on your laptop, right? So which is, sometimes this BIOS key comes with the manufacturer. So but you wanted to break this manufacturer key, then what you do is you bring the device to your home, because you can buy it, the device, but you don't know the key, the BIOS key, manufacturer key. Then you bring to home, and then you connect the electronic probe, and you can the control, you have a control. You can give multiple inputs, multiple plain text, but you don't know what is the key. So you will give the multiple plain text to this system, and then you every input, every plain text, you will get one trace. Then you get a trace means. So just I'll give you yeah, the trace like something look like this. Okay, this is the trace from AES trace. So this could be, you can even from this trace you can say there could be some 10 rounds. Okay, there are 16 rounds. Okay, so that you can literally, you can even see. So the trace means the trace, this is measured using some probe, power probe. Okay, so you'll give the, you'll measure this type of traces. Sorry. Okay, there's some noise. It's fine. So you can measure this type of traces for every run. Okay, and once you have this type 10-15 traces, I mean 10 every 10-15 runs, then you can construct a model. From that model, you can basically decrypt the key. So for example, there are I'm talking about models, right? How you can construct a model. So I'm not really going to talk about how you can construct a model, but that you can find it from one of the paper that I was working on like few years before. So that paper you can see. I mean, there are a lot of literature available on this one, how you can identify this attack and how you can mitigate this attack. So coming to the model again, there are models called template attacks, are like machine learning models, are like the models that you basically you construct the models in order to detect the key. So basically, in the template attack, what they're doing, they're constructing a template using multi-Gaussian model. I'm constructing a using multi-Gaussian model. Then after that, for every plain text, I construct this template model, one model, and by checking my X box substitution box, and when the key comes, on real time, because this is something you wanted to do. There are two phases, so offline and real time. So in offline phase, you really construct the model, and now you connect the model when on the real time. Okay, because offline you do everything at your home, and then you have a model everything. Then because this device is mass produced, right? So the manufacturer might have the same device with a similar model, right? Similar. So then I can put my probe on a real time, and then I can extract the key from others one. Okay, for example. So yeah, there for template, I'm using multi-Gaussian models. For at the same time, from these traces, I can construct some machine learning model to learn the key. So here, instead of, as you see from the right side figures, instead of my work factor here, instead of time, I'm talking about the traces. So can I decrypt the key? The success rate, like for example, here as you see from the figures, the success rate is 100% when I use 20 traces. That means when I run this particular device 20 runs, 20 times I run this time. So for sure, I'll get the key, right? For example, okay, how you can mitigate these ones. So for example, you can mask the values. For example, I'm saying that this particular operation in AES could give this type of value. I mean, could cause this type of side channel, right? What if I do dummy values instead of when it is happening? Maybe I'll introduce dummy values, okay, dummy information instead of dummy operations, so that it masquerades and it confuses the attacker. I mean, he might not get the. So that's why, for example, the down figure. So I see that I'm applying some kind of mask AES. So there, whatever the traces I use, even the 40-50 traces I'll use that using traditional approach. I cannot basically break this system. However, if I use machine learning approaches, I can break even masked AES also. Okay, so that's the procedure. So here, what we propose is a key-based moving target defense. So what I'm saying is, there's a mitigation technique, defense technique, how you can really protect this from this attack. So, for example, what I'm saying is, you have a device at your home, like you wanted to profile it, right? What if I change the key after every 10 runs? Okay, it's like similar, similarly like username and password. So for example, you try the password for 4-5 times, then what happens? The 6th time, it asks you to change the password, right? Similarly here also, what I'm saying is, change the password automatically, change the BIOS password automatically, because maybe you can write a module with thousands of keys, okay, thousands of like tens of keys, for example. So whenever the user is trying every run, you can rotate the keys. So then you can, the attacker might not get the key, right? That's how you can, you can protect the devices. So this is something, but this side channel on now, for example, yeah, whenever you see, I mean, this is something happening, let's say 2 decades before, but nowadays, when you release, when, for example, in your phone or in our device, in our laptops, when the processors are side channel resistant. So this is the, like, whenever the processor is releasing on market, it has some kind of levels, level 1, level 2. It has to get certified from a common criteria, CC common criteria. There is a standard. It has to be certified accordingly. So it is a side channel comes under level 5 certification. So for example, you see any, I mean, if you go to the clear documentation or like a more specification of a product on the processor, then it will they clearly specify this is level 5 side channel resistant processor. Then only they will release to the market. I mean, not everyone. I mean, the real, very good processor manufacturers, basically they invest a lot of millions on side channel, resistant in order to product from side channels. They have their own equipment, and most of my friends also working in those companies. That's how somehow I came to know about the procedures and somehow. So that's about side channel attacks. It's a kind of one advanced class of attacks which is pointed to embedded devices. So do you have any questions before going to the different class of attacks? I mean, now I'm going to talk about different category. Here, any questions? I'm happy. I know this. I'm only presenting 1, 2, 3 slides. I'm trying to explain a bigger concept, but yeah, considering time considerations, I cannot really go in technical depth here. Anyone? Any question?
Yeah, anybody? Any questions? Muralidhar, do you have any question?
Yes, sir. Yes, sir.
Yeah,
Thank you for.
Yeah.
Sir.
Please.
Yeah. Sir, here you had mentioned that side channel attacks, right?
Yes.
Sir, how that power analysis attacks can be cope up with side channel attacks, and how can we classify whether it can comes under power analysis or a direct side channel attack, sir?
No. Side channel attack can be occurred in a different ways. Like it could be power, it could be time, or electromagnetic, or EM. It could be even other, even caching. So power is a one class of one of the way to achieve side channel attacks. I mean, so it could be time response. For example, you might, for example, you're running an operation, okay? Then there is some delay happening, okay? Then you can measure the delays from the time that the amount of response you get back from this particular operation. You can say that's one side channel. Power is another side channel. So coming back to the power side channel, when you are running this particular sensitive operation, I mean, whether it's a AES, a DES, any algorithm, any cryptographic or any sensitive algorithm, you know that when there could be a place you might see a spike, because for example you are doing addition, okay, very plain was. What happens is addition, the power is plain, okay, the power measurement is 5 volts, for example, like 0. But when you're doing multiplication, you definitely see there's a spike, right? Because multiplication is heavier operation compared to addition. Yeah. Yes. So that's how you can decide the multiple. So there's something happening on multiplication in that particular sensitive operation. So you can construct a model accordingly.
Okay. But most of the standard devices like processors and all, we'll work on some standard machines, no, sir. But most of the standard machines do particular about this attack mitigations and all. But
exactly.
Still, how?
Yes. So I will say still how is happening. That's a good question. Okay. So this is something some 2 decades before, 2 decades or 1 decade, 2 decades before, we have the processor architectures are really different, right? Now we have multi-core and different ones. So that time the devices are susceptible to this type of attacks. But now modern processors are not susceptible to attacks, because now even though there are regions, they even someone found on a Bluetooth, there is a the
Sir,
Regularly, I'm doing 5 kilometer walk.
5 kilometer walk. Okay. No, this is incline, no? Climbing up.
Incline.
So cardio, sir.
It will get
I
more
think someone. Okay. Coming back to the question. So what I'm saying is, few decades there was this type of attacks. Nowadays, what they're doing is, whenever a manufacturer building any processor, they are first of all testing with respect to side channel attacks. So that's a one category. They have to do the risk assessment before they're releasing their processor into the market. Because even though you still hearing side channel attacks even nowadays. For example, recently we heard about the Bluetooth. For example, the Bluetooth channel is open, okay? And you're running some operation, some unwanted noise is leaking from Bluetooth. So they recently some team from, I think, Belgium, they showed how it could happen. So there are still ways the attackers find a ways to identify side channels. Even cache memories, for example, you in a cloud memory in cloud, or like sometimes you use the same cache memory for different operations. Like someone can come and they use a shared caches in a some that happens. Right? You have one processor, okay? There are multiple processors. There are 4 processors, but you have a single cache, shared cache. So one processor can leaking another cache information, right? It's a shared cache. So it can happen. Still, there are chances. So what I'm saying is, side channel is nothing means it could happen anyway, not only with respect to power. It could be cache, or it could be time, or it could be EM.
Okay. Okay, sir.
Okay, thank you. Okay, so anyway, I think if you have any more questions, I suggest you to read, the papers on side channels. I provided here some link here. Maybe you can start with this one. This is we gave the really good examples on this paper, so you can go through that one if you are interested actually. So okay, then we can start with the other one, advanced attacks on persistent threats. Okay, so this is something more targeting from in a different level, not from embedded level. I mean, it could be embedded level, but it's a different pattern. Okay, as I said, the persistent, that means which is occur in a prolonged period, it's continuing to occur. So these attacks are really customized, focused attacks, which are really difficult to detect, nearly impossible to detect, and which basically the intention, their intention is to steal the confidential information and spread the malware. Okay, that's how APTs can be defined. Okay, so for example, if you see the CVE, Mitre, or CAPEC, these are the few organizations, specifically Mitre. This organization basically provides you one kind of one indicator, one naming and indicator for every attack. So for example, you see one attack happening today somewhere in the world. So see, they'll, if you notify the Mitre, then they'll provide, okay, this is an injection attack with some particular number. Okay, so they'll maintain all the list of attacks in database. So they'll also do the for APTs. So APT, they define, for example, this is something, if some some token is coming, okay, then what you'll give some name, right? Exactly. See here also some attack is coming, so you'll give some name. So here, for example, APT 29, APT 34. So APT 29 is basically targeting spear phishing attack on Pentagon. So Pentagon, what happened is some years before. So spear phishing is nothing but targeting specific individual. So it's not a simple phishing attack. What they do is they analyze the behavior of very high, VIPs in a Pentagon level. They know, attackers know these are the VIP people, and they have high level of access in their network. So maybe I target this class of people only. Then they'll understand their behavior, and then they will send specific sophisticated, emails to this specific class of people. And then if they click, there's a phishing email. Maybe they are, even though they are at very high level, they might not be cybersecurity professionals, right? So in an organization, you are like, if you have 100 people, 95 people are not cybersecurity professionals. So even the 5% of cybersecurity professionals still click phishing email sometimes. That happens every day. Even we see every day. So then it could, what happened, when they click the email, then the attack starts. Okay, it will not show immediate effect. I'm just so you'll know the effect after some point of time. That's a special special speciality about these APTs. So APTs has a flow. I mean, has a some, they follow some structure. So first of all, they do kind of investigation. So as I said, an example in this APT 29 spear phishing attack, what they did is first they're trying to identify the network and identify the list of potential entry and exist. Okay, so what they're doing is, who are the people they're working in this pentagon on the network, and then trying to identify. I mean, I'm talking from a more like a cyber physical world. I'm not talking really from a network cyber level. I'm talking from more cyber physical level. Okay, so here they're trying to identify the persons. Okay, these are the people, and in the second step, they're trying to exploit the weakness. So the weakness could be phishing email or like a USB device. So for example, considering the example of phishing email, okay, these people might not be cybersecurity professionals. So maybe they don't know the phishing, how a phishing email look like, because this is something from your ISO standards or like your NIST standards. So for example, some particular organization does not implement any phishing email or like a strategy or something. It does not have, this particular organization does not have any information security sessions, training sessions. So how the people will know about the, how they can classify whether it's a phishing email, whether it's a normal email. It could happen. So they know, the attackers will analyze this type of behavior, like they see what type of controls they implemented in the network, in their organization, whether there's any weakness, like okay, for example, the information security training is not done and the servers are not updated. Okay, so they slowly understand the network, the people and everyone, and after that, once he click the email, okay, then what they do is they don't perform the action. They just they do the command and control. They spread what they do is they'll have their command control server, and then from there they were trying to spread the malware. Okay, and then the importance, the main notion of this attack is stealthiness. Okay, undetected. They wanted to remain undetected for a long time. They wanted to gather the as much information from the organization or network, and once they have sufficient information, then they'll do the attack. Then they'll start exchanging the information. They'll gather the data and then they'll send it back outside. So that's how typical APT advanced attack, advanced persistent attack look like. So maybe there's another example. For example, so you have there's an organization, some critical infrastructure, okay, and in front of organization, someone started some campaign, okay, some campaign like free phone or maybe some campaign, and then they're distributing USBs, okay. So as an employee, they're distributing free devices. I'll take one USB device. So for example, this organization don't have the USB policy, for example, then he'll insert USB on the network. So then what they do immediately, it will when it is connected to the internet, the attackers will know. Then they'll spread the malware inside the network, and then they'll wait for the time, and then they'll start doing the attack. So that's how simple, that's how the attacks could happen from a cyber physical world. But okay, now maybe you can ask me another example from cyber world. Okay, so how can it really happen in a without physical interaction? So for example, you have a slow and enumeration attack. What they do is, for example, you wanted to perform a credential validation attack, or like you wanted to identify the username and password. Okay, then what they do is, like, if you try more passwords, then system basically nowadays the system knows if someone is trying more passwords, then basically I'll block from this IP, particular IP. Okay, then what they do, the bots, what they do is, the advanced attackers, they deploy multiple bots, automated tools, automated bots, and they will try username and password very slowly, very slow fashion. They don't supply the thousands of passwords at the same time. They supply very number of usernames per day, this few usernames, few passwords from one bot, another bot. Like if they have thousands of bots, they'll supply one. So such a way they will do, I mean, in a slow fashion for a long time. They'll try to, continue their attack until they get success. That's one class of, advanced attack from a pure website, not, I mean, pure cyber world, not from cyber physical world. So it could be anyway. The APT can happen from a different classes, different types, different ways also. Okay, so here the coffee machine hit by ransomware attack. I mean, someone can think why someone is really hitting coffee machine. Okay, do you think is something is worth to read? Yes, it could be because the coffee machine, this day he attacked the coffee machine, and next day he might attack from the coffee machine which is connected to internet, and he can he can spread the malware to central server, right? So it could happen. Maybe it's not coffee machine, it could be another the device in health. Okay, for example, you are in a on oxygen, okay, on a ventilator which is connected. I know, I mean, you might laugh, but these days everything is getting connected to internet. Okay, everything. So someone can really stop ventilator. That's it. Right? It's the human life is in danger, right? So the cyber, I mean, for attackers, they wanted at the end, they wanted to have some, they want to have some gain in terms of money or in terms of other aspects. Okay, so now till now we're talking about two class of attacks. One is one attack from a side channel attacks from a embedded level, another attack from a APTs, advanced persistent threats, from a cyber physical world and cyber world, and now other attacks from a complex attacks from insider threats. So these are these attacks also really complex and kind of APTs also. The reason is you cannot really differentiate the internal attack from external attack, because internal attack means that the employee from a company, inside company, is performing malicious action. So for example, he wanted to steal some information from a company. For example, I'm in a financial domain. Maybe I wanted to know my PA. I wanted to get the personal user information from my all clients. Okay, maybe someone is from aerospace sector, so I wanted to know the blueprints of the designs. Okay, it's very so it could happen. So that time the insider attacks are much more complex to detect, because they have all the access. They're treated as normal users. So how could we decide, really defend from these insider attacks, and how could we really mitigate these insider attacks? So this is something we need to look in. So these kind of, till now we're talking about a risk assessment, right? So in risk assessment, we're trying to identify what type of attacks that could have on your organization. Like it could be side channel attacks, like just example, and it could be insider attacks. Here it could be advanced APT attacks. So once you perform risk assessment, you will try to kill the chain, attack the key chain. At least, if you can stop any, there is a, when you see any these kind of attacks, there is a pattern, right? So for example, there is some precondition is there, and attackers are using this precondition and exploiting the vulnerability on a given target. So here, if you can break any link of this chain, you can mitigate the attack actually. So, for example, the previous example, the USB policy, right? So, the campaign, there's a USBs, and then if you implement the USB control in your organization, then you cannot inject he cannot insert the USB. So you are killing that particular chain, right? So for example, here another example. So here there is a application. So can you see on the left side, there is a precondition, there is internet facing, okay? If there is an application, okay, which is internet facing, that's a precondition, and the attack method is kind of injection. So the attacker want to do some injection attack, SQL injection, whatever attack, and which has web interface. Okay, basically your application is hosted in a web and which is internet facing, and he wanted to perform injection attack. Then he can disturb the application, and from when the target is application, some your HTTP server, for example, and which could cause financial loss. It could leak the information leakage. So if you can kill anything, for example, if I kill, okay, my application, I don't want to be internet facing. So for example, this is the internal system that you are building, okay? Maybe when you are having your organization, you don't need to really expose your all websites to outside, right? Because there are some websites which you use internally inside our network. So when someone is accessing from outside network, just we don't need to put it outside. But there are some scenarios you need to put it in outside. In that time, you cannot basically kill the child. You cannot, that time you need to accept the risk, and you need to implement the suitable controls. So that's called risk acceptance. So you need to accept the risk, and you have to accordingly you have to implement the controls. But if there is a chance to kill this child, try to kill before even deploying the solution. So in APTs, the definition of APT is important, and breaking the kill chain is another important factor. So these are the two terms that we need to understand, from the perspective of advanced attacks. Okay. Now I'm going back to the challenges in current solutions. So for example, you have what type of challenges we have, and what are the current solutions we have, and what the how we can address the advanced challenges. So the current challenges we have, like you wanted to find the operational network attacks. So what I mean is, in the really in cyber physical world, for example, if you consider any industrial IoT network, okay, I'm going to give another example. Industrial IoT network, there you have it, you have manufacturing process, okay. The manufacturing process is connected to network, some network, okay. So this manufacturing process basically has a OT network. It's called OT, operational network, and there's another network called IT network, okay, which is like which is connected to some router, and then you can basically monitor the what is the manufacturing going on, okay. So sometimes you need to, there could be a relation, this operation network and this IT network. So you have to identify what are this type of relation between these two networks, and you need to understand what are the nature of attacks, and you need to address it from APTs, right? The current solutions we have, basically you have IDS system. Basically, they are more signature-based systems and not anomaly-based. The reason is like in most of the enterprise networks or companies, they don't want behavioral solutions a lot. I mean, they don't prefer, because the behavioral solutions, you don't know, I mean, you don't know the reason why they are mitigating, why the false positive rate or false negative rate could be high, okay, in behavioral solutions. But in signature-based solutions, the false positive rate is very less. So they prefer the signature-based IDS solutions or traditional SIM tools. But in order to address this type of APTs, like advanced attacks, you need to know what is the you need to know what is the root cause of attack, okay. Instead of simply denying the attack, you need to understand why happening, from where it is coming, and you need to know like how it's happening. And another one, you need to see, I mean, at some point, the human intervention, human should be there to identify the class. Sometimes you need to, even though we have like such a advanced techniques, but there's always the human intervention should be needed to properly classify that. That's what basically, even so, for example, whenever the advanced attack happening in any organization, there are like level 3 people will come into picture, then they'll still help the systems to properly identify the attacks. So that's a important thing. So once you know the challenges, and you can ask the policy management, I mean, you can go back to the C-level suit, and okay, these are I have the goals, okay, these are what I wanted to achieve, and please commit, please adopt some policies, please put policies into picture. Then we can, the security implementers, or someone can implement the security controls. So I'm just keeping this slide, okay, because we don't need to really go through that one. So that's how in the security life cycle, we have completed 2 phases, right? One is the policy management, one is the risk assessment, right? In the policy management, something more about goals and challenges, and the commitment, high-level commitment from C-level suit. In the risk assessment, we saw what type of attacks are there, like side channels, like advanced APTs, or insider threats. Now we know what type of attacks can happen in our organization, Now we can implement the control accordingly. Like for example, this is a typical industrial network with IT and OT network. So as I was saying, right? So if you consider there's a, for example, there's a medical manufacturing. Sometime before I was working with a medical manufacturing company. So that time I came to know that so there are like field processors, the field systems, okay, and they have the manufacturing lines, okay, and these manufacturing lines are connected with the external router with IT network, and you can supply the recipes. The recipes means nothing but some instructions that you wanted to feed to this manufacturing line, okay, this control network or process network, okay. So you feed it from IT network sometimes. So then, but the thing is here, the important notion is this IT network and OT network should be separated, right? So that's why you see here the center of the figure. There is a firewall is protecting, separating the IT network and OT network. So that's how you can separate the network, so that somehow you already started building security control, right? So each and every layer, in the right side, you see that each and every layer, I'm deploying some agents, so this is something now, the first slide, I think I was talking about traditional security system, right? The physical security from back in centuries. So now we can map here, right? Each and every layer, you're adding some security controls and you are separating from your IT network to OT network. That's how you can map the physical security to the modern cyber physical world. So each and every layer, you can implement your controls. Like you can put more device, more tools, whatever the tools. Like for example, in a in cyber physical industry, I know Dragos. I'll tell you, Enjomi networks. There are some tools they're specifically designed for industry networks. So those agents you can deploy here, and then you can monitor the traffic, OT traffic basically. So that's how once you have here I'm talking about more like putting everything in together. So people, their devices, the physical devices and the IT devices, whatever, everything, you take a logs and events, you collect the logs and events, and you have a APT detection prediction engine, and you do the mitigation, and you do start doing the risk assessment again. So if you see in the previous day, the risk assessment comes at the first, okay, but here it comes at the end. I mean, it's a loop actually. So there should be another another arrow should be here, but it's a basically loop. So you identified the attacks, okay, you implemented the, first of all, you have a policy management, and you did the risk assessment, and after that you implemented the controls, and you started doing the monitoring, and you're detecting the events, okay, and you did the mitigation also. That means you identified attack and you mitigated. That means your system is not up to date. That's why you see attack, right? That means you have to do proper risk assessment again. So that's how the loop goes on. I think someone has some question. No. Okay, so I can continue. So that's how the life cycle comes into picture, right? So it's a loop from once you've done the mitigation, you have to come back to the risk assessment. So now, okay, still now we are talking about the control implementation, right? We covered 3 topics: policy management, again, policy management, risk assessment, and control implementation. So the tools that you, and here I haven't mentioned what type of tools you need to implement here. This is subjected to typical given infrastructure, right? So if it's a banking, if it's medical manufacturing or some other manufacturing, depends on the depending on their need, they'll implement the tools, whether at the product level or at the network level. It depends on the whole according to organization. But once you implement the control, once you deploy all the tools, and detection tools, SIM tools, then you do the detection, right? So you do the controls. The other step is detection. You have to, and you have to continuously monitor the network. You have to see what happening in my network, right? What happening in your network, that you have to see, and you have to identify the, you need to. So there is a kind of centrally, there's a data hub basically. So basically there are we call it as a information lakes, like data hubs, where basically you collect all the event from a different system, logs from the different systems, because you deploy your monitoring agents you implement the controls and you deploy your monitoring agents on a different system. Then you get the logs every day, because every second they'll set the logs, they'll set the information, they'll send out the information. So this all the information is coming to some central data hub. From this data hub, now we can start doing monitoring and see whether if there are any spikes or if there are any anomalies. You can apply machine learning algorithms like intrusion detection, or it could be supervised learning or unsupervised learning algorithms that you can deploy on here to see is there any anomalies compared to the normal traffic, a normal system. Then once you identify any attacks, according to you can provide corresponding level of mitigation. So here the other topic is what is the machine learning or AI role in cybersecurity, right? So it could be not only for every time when we're thinking the machine learning is only useful for intrusion detection. It's not true not true always, right? So machine learning or AI could be helpful in not only intrusion detection, it could be helpful in intelligent orchestration. Sorry. So what do you mean by intelligent orchestration means, for example, you have a mitigation. So there is an attack that you wanted to mitigate, right? Then there could be multiple ways to mitigate this attack. So the orchestration, the intelligent machine learning could also helpful to identify the best suitable policy to implement this particular security control to mitigate this attack in a given time. So or otherwise, take another example, resource provisioning. Okay, it's something very similar. So there's some attack happening, then you needed to allot some resources to this particular attack. Okay, so you need to, because the attack, sometimes attacks can happen for over a long time, right? So then you need to, then what happens is machine learning can help you to do the resource provisioning. The resource provisioning is very popular concept in other domains, like for example in communications, right? So you wanted to see on fly how many devices you need to achieve some particular computation, right? So similarly, here also you can apply machine learning on resource provisioning with respect to cybersecurity. So the security analytics or context learning, like context is also very important when while you are deciding one particular attack or not, right? You need to understand the concept behind. So machine learning, that's how the machine learning or AI plays a crucial role in cybersecurity in nowadays. Okay, I mean, I know there are some, as I said, like last time, like I was sometime before I was talking that companies, they prefer a more like signature-based intrusion detection. But nowadays, I see they're adopting a lot of machine learning tools in their cybersecurity system, to have to get the real benefits. Okay, so here I just introduced talking about security network analytics. Now we are at the detection. Okay, so we completed 3 parts. Now I'm just only concentrating in detection part, right? The detection is like, let's say, major component here, but I don't know how much time I have. I think I have maybe maybe roughly 20 minutes. I think 15 20 minutes.
Yes.
And thanks, Sandeep. Yeah. So maybe we can complete before that. So yeah, in the security network analytics, so how the security analytics playing a role in your detecting any attack, like so in detection, right? So here, if you see that traditionally we have a web stack and IoT stack. So web stack means the OSI layer stack, which everyone knows. We have a IEEE 802.3 Ethernet or like IP6 TCP, but coming to IoT stack, which is a bit different, right? I mean, different means in sense of the protocols that you use is a kind of different. So once you have IoT and web stack, how we can basically take consider the important features that are useful in order to detect any attack. So for example, from a physical link or physical layer, I will say, I mean, from one layer, I can consider firewall logs or log on failures or audit data or maybe device specific information. Like from a MAC level or internet layer, I can identify the number of frames or channel state information or multipath channel responses. So it could be, at each layer, at each level, you have a different type of information that you can collect. And from this information, you can perform the security analytics. I mean, security analytics is nothing but the insights, the behaviors that you can capture from your logs, the information. So here, so here we are working on one of in the previous company. I was working on a behavioral-based multi-layer monitoring technique. So what we are doing is we have, for example, you have a cyber physical world. So I'll give where there is infrastructure where is a medical manufacturing infrastructure for example. So there is a room, a room is equipped with a window, temperature sensors, air conditioning and temperature sensors. Okay. Then we wanted to see if there is how the cyber physical attack can happen on this monitoring sensor. Okay. Then you can ask me immediately, if the cyber physical attack happens on this sensor, why I need to care? Because we have to care, because if you change the temperature to to the minor degree, from 20.0 to 2021, okay, that could lead to the entire manufacturing line could be, you should discard the entire manufacturing line, because the medical manufacturing line are very susceptible to I mean, like very prone to errors based on the temperature. So the temperature is very important also. So what we did is we kind of we have some test bed. So what we did, like we collected the attacker from attack perspective. So we log into IT network. From IT network, we got the access to this sensor, temperature sensor, and we change the sensors. Then we see the effect on the manufacturing line. So for example, if you wanted to detect such attack, what here then the information here, you need to get the information from both, right? IT network, and you need to have access to OT network, right? So that time you basically, we cannot decide on a traditional OSL layer stack. So instead of talking about the OSL layer stack, something we can talk about more like a features instead of a layers. So what I'm saying is, so you get some feature like the temperature values, the traditional normal temperature values should be one feature. Okay, this is my regular temperature values. Okay, and the another feature, it could be from your IT network. Okay, what is my amount of information that I'm sending? Okay, for example, I'm every 5 seconds from node A to node B, I'll see 10 bits per second or 10 kilobytes per second. Okay, that's my another feature. Okay, if I can capture this type of information, maybe I can detect this particular attack. This is a complex attack, right? Because it's happening in two different domains. So attacker is coming through IT network and is changing the OT information. So when you capture such information from a different, from feature perspective, then we can identify this attack, right? So in a plain example, I have another. I can give you more pictorially. I'll represent in another slide. But now, how we decided is we constructed a behavioral model, some behavioral explainable AI model, behavioral on using constant learning. We constructed a model where features the network in the network, the features represent a nodes, and each node are connected. And if, for example, you see that there is a DOS attack, someone is trying to connect it to your network or like router. Maybe first of all he's doing some kind of DOS attack, for example. Okay, then he's trying to disturb the network. Okay, so then we see this pattern, some network the attack happening on the IT layer, and at the same time you also see some values are changing compared to normally on the OT level. So that's how, if you can identify such relations, then you can basically we can basically detect this complex attacks. The intention behind building this technique, we wanted to detect the attack, and we wanted to provide some root cause of attack, some explanation why it's happening, because most of behavioral machine learning techniques specifically to cybersecurity are kind of black box, because we don't, for example, I'm not saying deep learning are they are not good, but they are really good. But if you really have some explanation, because for example, in deep learning or modern machine learning techniques, it's very difficult to identify how the inside layers are structured, deep layers, net layers are structured. So, but if you have explanation, so it's very good for, especially for cybersecurity. So we wanted to try to bring that type of flavor, and we wanted to human in the loop. So we wanted to have a human intervention. Not only like it's not fully automated. For cybersecurity, personally, I don't prefer fully automated system because that might not work. I mean, you might have more false positives also. So here we built a graph model. So initially we have a graph models. We can have a statistical models, or you can have a machine learning models. So for us, we took graph with the machine learning models that we took it for to detect. So what we did is, so from monitoring, we collected the system behavior information, network information, and operator information, and other information. So we collected the data from different layers, I mean different domains, not let's say different domains, for operational domain and IT network domain. And we constructed a relational model, relational graph using constant programming. And from this graph, we say we can detect the anomalies. Like for example, when it's detected, we can say whether it's a fault, whether it's attack, and then after that we can provide some explanation. So if someone wants to read that one, maybe you can read, the down. I noted the paper name, so maybe you can start if you want. Someone is interested, please read the paper so that it give you the more explanation. So on a very short, so we use a constant learning technique. Basically, this has a solver which as it takes the input as a constraint, the relations between your variables and the observations, and it will provide you the anomaly. So how I'm saying is, so this is the example that we can see. So you have a device, for example, IoT device 1 and IoT device 2. Okay, so here you have a temperature as a one feature, and network delay is another feature, and the jitter is another feature for device 1. Okay, and then device 2, you have similarly like same thing, right? Because every device is similar. So we took the similar one. But for example, here what happening is, normally you see a relation between temperature and network delay. Okay, but you might not see a relation between IoT device 1 to IoT device N with the jitter. So you see some new relations with every relation we give some score also. So if you see different relations that which is not expected, and with a different score, then you can see that okay, there is some kind of this relation we don't know. The score is also not enough. Then based on some threshold, we can decide this relation is not expected, and this behavior is not unexpected. Then we can decide it is a attack. That's how we can decide a constant. That's how we can construct a constant networking graph. So I'll say more details you can find on the paper so that you can find it there, so that it's really helpful to understand. So here it's a little short time. I cannot really provide a lot. So I think those are the it's a overall thing that we discussed. So we discussed about policy management and risk assessment with this different class of attacks, and we did the control implementation. So we saw some architecture in a given OT network, in a OT IT network, and we discussed about some detection tools, how it could be, because the modern tool should have, as I said, it should have some explanation. So we should adopt explainable AAA, but especially for cybersecurity, and some mitigation. These are the some key takeaways. So for example, here, the SIM tools I was talking, specifically for industrial networks, Enjomi networks or Dragos are, good to start. Some good monitoring solutions, and Splunk is very famous for IT networks, and some other detection tools. You have Akamai and F5. There are also some DNS or some security tools that they're really decent for identified attacks. I think that's all from my side today. Any questions?
Good afternoon, sir. Sir, I'm Shanmugapriya. So I want to know if there is any tool available for this risk assessment. So automated kind of tool.
Okay. Risk assessment. Okay, this is something I was working on internally in our. So there are some risk assessment tools I don't know exactly by name. This is also, yeah, I don't know actually by name actually, but I saw some tools, but I don't know exactly. There's a threat as instead of risk assessment, I'll say threat assessment tools. I think that's a more feasible word that you can find easily.
Okay.
I don't know
So
exact
we-
name.
So we were trying to do a work on, we were trying to quantify the risk. So I had some problems with that. So can we contact you later, sir, to discuss how the work can be proceeded,
Yeah, you can
quantification
talk to
of,
Sanjeet. Sure, you
yes.
can talk to Sanjeet, and I'm happy to help you. I'm
Yeah,
happy
yeah,
to.
I will connect you. You just
Yeah, great. Thank you, sir.
Sure.
Thanks a lot.
Yeah. So actually, the coming to risk assessment, I'll talk about 2 minutes. So I'll talk about. So actually, yes, we are working on a risk assessment. I'll not reveal where. So the risk assessment tools are a bit less in industry. They are more like it's a detection tools you have, but risk assessment tools also varies specific to industry need. Okay, because it depends on the specific industry metrics, right? So whatever, because
Yes.
you need to, sometimes some industries follows the quantifiable, non-quantifiable approaches, right? So if it's non-quantifiable, basically they categorize low, medium, or high, okay? And some industries follow quantifiable, like for example, CVE, I think you can start with the CVE, MITRE, CVE, they will provide you already some specific risk score for each class of attacks.
Yeah, that is what we were also trying to do.
Exactly.
We
From
ended
that,
up with something, but I am not confident enough whether it is really contributing to anything, or I'm just playing with it. I just wanted to confirm.
yeah, but the problem is the CVE is specifically for given a risk or given threat. But what happens? Consider industry. Okay, industry can have multiple risks, multiple threats on a given product. Okay, one industry could have multiple products or multiple infrastructure levels. So how do you quantify the risk when you have multiple threats? Okay, then you need to come up with some modeling, risk modeling technique that can combine all the risk score with the weighted scores, for example. So it's all that's, but this really depends on the specific company needs, because some company will accept the risk at certain level, and okay, for example, some company don't care about some threats, okay, because they know this threat happening, but they are not applicable to that particular company. So you need to understand the company structure. I mean, if you wanted to target specific companies, specific organizations, specific industry, so the risk assessment, risk modeling definitely varies.
Yes, here we were doing it for users. So as you said correctly, we also had a weighted score where for every user it was varying. Yes, what you said is right, sir. Yes.
Yeah, exactly. Yeah, that's something. Okay.
That's great. Thank you, sir.
Yeah, anybody else? Any questions?
In the chart, I think I see some questions.
No, it is related to attendance. Yeah.
Sorry, yeah.
Yeah, anybody else? Yes.
Sir, this is Muralidhar again.
Yeah.
Yes.
Satyanarayana, sir, it was really good we have, this kind of things here. Sir, this question related to privileged insider. As you had mentioned that you are working for a financial firm. Sorry. So, sir, how since it is a complex kind of attack, so how can we detect? First of all, how can we detect a particular person who is actually threatening to the system or not? First thing. Second thing, what are all the available tools that we can assess on real time networks if the privileged insider is available on network at a hostile environment, not in a like a physical environment, hostile environment.
Okay. First of all, I'm not talking from the perspective of financial domain, unlike what I'm working there. So I'm just talking from a very general perspective. So that's not something not related to what the company that I'm working now. So I cannot really reveal those information. So
okay, sir, no problem.
Yes. So generally, inside a thread, there are user behavioral analytics tools, UBA. These are the tools that are specifically really addressing the insider attacks. I mean, insider class of attacks. So, for example, in Splunk also there are if you consider Splunk, which is very well-known tool nowadays, it has inbuilt components for insider threats. Okay, to detect insider attacks. So coming to the methodology or like the algorithm that you wanted to use, it is depends on the scenarios again. For example, here in this example you see, I haven't really went through the slides. Okay, I mean completely right because the time factor. So here the user for first scenario, user didn't not, who did not previously use the removable drives and work after hours begin the logging in after hours using a removable drive and uploading data to WikiLeaks. Okay, so that is simple scenario. Then how we can do it depends on the features that you consider, right? So for example, here actually I had a paper on this one. So if you wanted to look into, you can search my profile, then you can get it. Okay, so there
Sure,
what we are doing is we are considering the different features, like for example timestamp, and sometimes you need to consider the email content also, what type of email he's writing right to outside, and what type of information he's downloading, whether he's downloading structured, unstructured text, or HTTP or email, like the amount of data. So it's all about the features that you consider, and then how you can build the model.
Okay.
I mean, that you're talking about another question, right? The hostile environment. I mean, that means the hostile environment means, okay, in regular, every user, for example, I'll give another example. So you have 1,000 employees in a network, okay? Real employees, okay? So let's say, how about constructing a model for each employee? Okay, which is very cumbersome. You cannot really construct, right? But how about constructing a simplified, unique model for representing the behavior of 1,000 employees? Okay, maybe then you cannot even sometimes it's more false positives. Then what about maybe build 10 models, like group these users in a different groups. Okay, each group one model. Okay, one different machine learning model or whatever statistical model, whatever the model you want to build. Then you can compare with this model, right? The attacker, the insider. So surely attacker should not fall into at least this 10 models. He has some kind of anomaly score compared to each model. So that's how we can start the things. Do you agree?
Yes, sir. Okay, thank you, sir.
Okay. Anyone else?
Yeah, hello. I'm Ashish. So I have one question that, yeah, are you getting my voice?
Yes, Ashish. Yes, please.
Yeah. So my question is that in order to analyze the IoT security, like that for IoT security analysis, is there any threat modeling tool? So because the data are quite large, so how to handle the data for the modeling purpose, like for visualization or for analysis purpose?
Yes, in AWS, I'm talking about AWS or like Azure, they have IoT modules. What you need to do is just you need to feed your data to them.
Okay.
There are, I mean, it's a very easy to start off. I'm saying, because AWS sometimes you get free versions. Sometimes if you want to start up, so but AWS, I'm 100% sure. I work bit, but not on much on AWS IoT. But there you can start analyzing the data very easily. Yeah, even okay. That's IoT. I was talking about AWS models, like AWS IoT system. But normally Splunk also, if you connect your data logs to the system, then you can start working on it with the data. I mean, specifically to IoT landscape, there is a open IoT. There are some frameworks that you can use, but I have to get back to you specifically to IoT. But AWS IoT, I'm sure it will cover a lot.
Okay, thank you.
Yeah, anybody else?
Yes, sir, I have one more doubt, sir.
Yeah,
It is
please.
like the IoT sensors are collecting data. So the confidentiality, integrity, availability, the general measures what we apply for regular traffic, does it apply even for IoT device? Because it is very small. So does it have support to do all those things?
Okay. Yes, that's a good question. I mean, CIA, I mean, depends on the devices, the data you're collecting from the context, from which context you're collecting. And nowadays, the IoT devices are even small, but it is nowadays the processors are coming, they have this technique, right? For example, who is enforcing this one? For example, you are getting a IoT device, means you are not basically, you never, I mean, most of the cases you don't directly collect from IoT device itself. You collect through a router, right? So router is responsible for the connection of the maintaining the number of IoT devices, right? So whenever you are initiating a connection, IoT device is exchange the information with the router with the specific keys, right? Then
Yes,
you have an
what
interface.
Okay, from device to router. So when the data is sent, so is there any means, because that forms a layer where the attacker can do the launch the attack? Yes.
Exactly. Then you need to look into IoT blockchain concept. That's where you can. Yeah, this is. I mean, that sounds a bit difficult, but there are chances, because in even the blockchain concept also, you don't need to do the proof of computation. And I know the IoT is like very sensible nodes. You cannot do the computation, but there are concepts you don't need to do the computation. There is other procedure called staking, right? So there are some other procedures that give you the assurance. No, we was working on some proposals, EU proposals, sometime before, like 4-5 years before. We are introducing these concepts. Actually, we wrote some proposals with this, whatever you're talking. So how you can ensure the accountability on remotely for at a processor level. Even I'm talking about a processor level, not even at the device level.
Okay, sir. Thank you. So as of now, there is nothing like when the data is acquired and sent, it is not in a very safe zone.
As of now, I don't say nothing. There are some, I think, industrial, let's say, industry-wide already deployed networks. They might have something which we might don't know exactly. But there are some basic controls. I'll say the blockchain is a kind of new to product complete, CAA, like entire confidentiality, integrity, accountability, everything comes in one row. But there are some other systems which might protect confidentiality. Like for example, confidentiality can be protected easily by exchanging key, right? You have a key that has not which router and device itself knows. Okay, then when they exchange the information, you are protecting confidentiality anyway, right? But what about, for example, if you want to protect integrity and accountability? Now the question comes: is there any existing mechanisms or not? Because integrity also can be protected from verifying the hashes and these things. But as you said, it is subjected to the computation power.
Okay, sir. Thank you.
Okay, anybody else? No? Okay. Okay, then thank you, Dr. Satya, for an informative talk on advanced persistent threats. And I think many of the participants will start doing research in this area after listening to your talk. So thank you.
Thank you so much.
Thank you once again.
Thank you, everyone. Thanks to everyone
Thank
for
you.
your question. Thank you.
So dear participants, we will have next talk after 15 minutes. So please join back.